we have seen, like creation, storage, uses, and archival, and in finally destruction of the data after some retention period. So there will be a certain time afterwards you may not require that data, rather than you need the particular hardware or where you are storing the data that is more critical. So after that you can vanish your data or you can destruct the data properly. Afterwards, we have studied the software development life cycle. So there you need to do a few steps while releasing some software, uh, starting from the planning, then defining and designing. This portion would be done by some architect. You have to define properly and then some designing, how to start, what model you need to follow. There are some certain models, among them which model you need to select, what is your budget. So accordingly, architect will decide what model need to be followed. Then it coming to the building and testing department, where the engineer or developer will write the code and do the testing, and he will do as per a model suggested by the architect. And then finally the deployment in the market. There you can gather again feedback from the customer, you can modify. That too also depend on what kind of modeling you are going to use. So there few steps we have studied: planning and requirement, defining the requirement properly. Requirement should be defined, what is exactly industry or some organization's requirement, and designing the product architecture. So architect will do this work, and then building and developing, that probably work may done by engineers like you, writing coding portion. So you are not concerned about this architecture and other things, but people who are belonging to this particular department, they will suggest, mostly experienced people will do this work. And for newcomers, they will give a small segment and they will work in this department. And then the testing the product at the industry, software industry level, they will do the testing whether it's functioning properly or not. And testing also depends on what kind of models you are using, because now we are going to study waterfall model, and next is some spiral model. So these were the general steps in the software development life cycle. And once you developed and released in market, you can do your advertisement and you have to provide the maintenance. Also some problems occurs, and sometimes what would happen, sometimes you need to release only the product, you need not to take care about that. Sometimes what would happen, industry or users will ask you again to add some functionalities, so that also you have to do. That is coming also under the maintenance. So from here we are going to start SDLC models. So there are various software development life cycle models defined and designed, which are followed during the software development. It's not like that you can start from the single end. There is proper agenda, like you are planning to build a one building. So what you need is, first you need the land, and then how to put the foundation. You have to verify what kind of soil inside and what its strength. Everything you have to take care. Like you can take example of Ram Mandir. So they are finding what kind of sand is there, and if that Ram Mandir stands for 100 or 200 years or 500 years, how much foundation required. So similarly, afterwards they will start designing, architect will do, and then material and other things. Same way in software also, it starts from the zero, and complete model will be available in front of your eyes, and how it's going to release in the end. So part by part work will be done by some different departments. Models are also referred as, in the software industry, software development process model, and each process model follows a series of steps unique to its type to ensure the success in the step of the software development. Most important and popular some models are available. Among them, first is waterfall model. So it was firstly developed or oldest model. It's not very much familiar in the software industry and not feasible, especially what kind of system now people are following. But this model was derived from the hardware companies, like you can say some companies making some guitar. So from step by step it will start. So waterfall model will act as how people were following in the hardware industry some model, and they just inherited and started in the software, but it's not so much feasible. What is problem here is once you done something, there is no possibility of regaining. It's exactly what its name suggests, waterfall model. So for example, water is falling from cliffs. If reaches one falling from one cliff to other cliff, uh, after that there is no recovery. You cannot go back and you can do some modifications. So that thing would not possible in waterfall model. Uh, but familiarly or frequently people followed in the hardware industry. So when software industry started, they must have some base. So as a base, they have taken from the hardware industry and they started modeling. Later on, many modeling came. Yes.
The slide is not visible, sir.
Is it problem with all?
No, sir, it's visible.
So I think you just refresh it.
Okay, sir, I will do that.
Okay, Varnika slide is visible.
Yes, sir.
Okay, just tell me on where we are right now.
So it was the models, like you were explaining about the waterfall model.
Okay, and now highlighted word is available, spiral model.
Yes, and now it is there.
Okay, some time
Now
lagging
it's
is there. Okay, little time lagging is there. Then other model is coming into picture was iterative model. You know what is iterations? Different trials you are taking, and in that way people started developing, and more frequently model use spiral model. So what highlighted thing is here, that is in syllabus, and the V model, this is not in syllabus. Some other models are also available, agile model and some rapid application development and prototyping models. Software engineers frequently study. So here we are going to concentrate on only four models, which are waterfall model, spiral model, and V model, and agile model. So moving towards the first model, what is waterfall model design? So here in picture you clearly see on the right hand side, it starts from something from the top and falling up to end, and it's starting from the requirement and going to the maintenance, and it's following some step like staircase like mechanism. What does it mean? When you assume some water falling from one mountain's cliff or from the top, it goes to the next level height, then next level height, um, better you say next level fall, then again next level fall, and next, and so on. Finally it will reach at the surface level. It's like that. So why we say waterfall model? Because water up falling from the one height to another height, there is no recovery or there is no possibility you can go back and you can throw water from the again from the last cliff to the next or proceeding cliff. So it's a process is like that. So from here itself you can understand, once you have started the project you have to move forward. You cannot go back and you do the correction. So it may be good for the software where you're designing in less time, but thing is, there is no chances of doing corrections or some mistake happened, means complete failure also may happen if you are following such kind of model. It may be useful where people are giving some less budget, you give to one company and that will do fastly, and it may give. So sometimes it may require, for example, some software required for making some entry. So for that purpose, it may be good for a small project, but while you are performing very large or mega project, then it's not recommendable at all. But the steps what we have studied in general way, those are same: requirement analysis, what kind of requirement, budget things would be discussed over here, and this portion would get uh, over here itself. It won't go to next step once you start system design and then again doing the analysis and then asking the customer something. That would not possible. Once fixed, and even they cannot ask to some add some new modules. Then the system design, then implementation and testing. The developers work will start over here. Architect in same to general what general block diagram we have studied would do the system designing, how to process, and then after the implementation testing, here integration like thing is not available, but for the one step or one department is connected to the other department in such a way, the output of one department will act as an input for the next department, and it's not possible in reverse way. It's going only in forward way, like the waterfall. And finally, deployment and maintenance. Let us see one by one what are functions waterfall model. Okay, I will just will not go by step so that complete visibility should be there, because due to some time lagging problem. The waterfall model was first process model to be introduced, and it also referred as a linear sequential life cycle model. So sequentially, step by step, you are going, very easy to understand. People who are starting their career in software industry, they can take one problem and they can start step by step, and you can easily understand also. In the waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping of the phases. So phases overlapping is not possible, because you cannot go back and do the corrections. There is no chance of repairment, you can say directly, not exactly repairment how we are thinking. Corrections are possible, but you cannot include many features, or you cannot go towards the next module. You cannot start from you cannot start in many iteration way. You cannot take lot of iteration, or you cannot start the parallel processing. A waterfall model is the earliest. Okay, fine. Waterfall model illustrates the software development process in the linear sequential flow. This means that any phase in development process begins only if the previous phase is complete, right? So you cannot move unless first phase is completed, because as I said, the output of the one module or output of one department will act as an input for the next department. So departments are so much dependent on each other, they cannot start the parallelly. But the other modeling are also available to overcome such limitations. Okay, waterfall model. This is same thing, some redundant terms. The waterfall approach, the whole process of software development is divided into the separate phases. In the waterfall model, typically the outcome, this thing already I explained. Now, one by one, what is discussed in requirement, as earlier we discussed, all possible requirements of the system to be developed are captured in a phase and documented in the requirement specification document. So here some documentation would be made as per customer's requirement. So point here to be noted is this module's functionality, or this particular module will get over here itself. After that, no modification would be possible. You will reach up to next step, or here more technically, you will step towards the next phase. System design, requirement specification for the first phase are studied in this phase, and the system design is prepared by some architect, and the not same architect what people are using or who are working for building, but in similar way some architect department is there. And the system design help in the specifying the hardware and system requirement and the help in defining the overall system architecture. Final, the implementation, the developers work starts from here with the input from the system design. The system is developed first into the small program called the units. So here a little bit parallel portion, you can start some units in some modules, and then the project manager will integrate all modules performed by different developers or engineers. Each unit is developed and tested for its functionality, and which is referred as a unit testing. Okay, so small fragments or modules, you can test it and then finally integrate it. Once you have done integration of all, sent to testing purpose, complete as a whole. So integration and testing, the units are developed in implementation phase, are integrated in a system after testing of each unit. So few units or many units get tested at this instant, and after that as a whole also going to be tested whether it's functioning properly or not. So once here tested, things get freezed, you cannot go back. The post integration entire system is tested for any fault and failures. Once you done the post integration, there is no fault, no failure, it's working fine, again freeze it, how in code tantra here we are doing. So after that nothing can be done. You can take nowadays lot of real-time example also. Once the functional and non-functional testing is done, the product is deployed in the customer environment or released into the market. So now the product is ready. You can so this is a client environment comes into the picture, and then you have to provide the maintenance. That's all about the waterfall model, how it's functioning. Maintenance, what is maintenance? There are some issues which come up with the client environment. To fix those issues, patches are released. Also, enhance the product, some better versions are released. The maintenance is done to deliver the changes to the customer environment. Okay, fine. So these phases actually, in waterfall model, phases are cascaded. You know what is cascaded? Means same meaning for cascaded. Cascaded amplifier you have studied. The output of one phase enters into the input of next phase. There is difference between the cascaded and the parallel, you know very well. The other in which the progress is seen is flowing steadily downwards like the waterfall throughout the phases. The next phase is started only after the defined set of goals are achieved for the previous phase, and it is signed off finally. Means after that you cannot do modification. So name is so called waterfall. In that way you can understand the whole story. Waterfall model application, where it's suitable, because everything is not suitable everywhere, but everything is not useless also. So in same way, it's maybe find good application, because if you are thinking from security point of view, once it's done means no modification can be done, means no intruder can introduce his things, or it's not possible like that. So hacking may be not possible. In that way you can understand its advantages. Every software developed is different and requires a suitable SDLC approach to be followed based on the internal and external factors. More importantly, depends on budget also. if a software engineer spends more time, means its rate will increase subsequently or accordingly, you can say. So if you are following some other model where many engineers are working on the same problem and they are doing in their own way, then what would happen? They are doing parallel programming, means on the same module, many are doing like chain like structure. So you are using more manpower to accomplish the same objective or same coding, but there are less chances of risk management would be less. So obviously it will increase the its price or budget problem will come into picture. But here in waterfall model, that scenario is not there. So you need less manpower also, department to department. Parallel things are not going on. Some situation where the use waterfall model most appropriate are requirements are very well documented and clear and fixed. So there you can use. Someone may ask where you can use waterfall model. Even in GATE exam also it asks to computer science student. So problem if defined very well, documented and very clear, then you can apply this type of model. Product definition is stable. It's not fluctuating. Sometimes a customer will say he need this thing, these functionalities, and after 1 week he's appearing and he saying take this much amount, I want this many modifications. So that would be not possible here. Stability required. Technology is understood and not dynamic. So technology should not vary so much frequently. Otherwise, what would happen? You will not able to use for next level or upcoming technology. There are no ambiguous requirement. Ample resources with required expertise are available to support the product, and project should be short, because if project is long and by mistake you done something wrong, what would happen to your industry and you can understand. Company will fire you. If you are making this approach for very large project and in the end some failure come into picture, means everything will go into vain. You have to start from the initial point. So those are few among the few points can be taken as advantages, few points can be taken as disadvantages. So as a summary, the advantages of the waterfall development are that it allows the departmentalization and the control. Schedule can be set with the deadline for each stage of development. So few good points you can take from here. Timely delivery may be available here, or possibilities more. A product can be proceed through the development process model phases one by one, not parallelly. Development moves from the concept through the design, implementation, testing. These were the steps, and these are the summary of the advantages. So same points I summarized here, because what I observed in your exam, you people are writing only a simple point. You're not explaining anything. Simply you have written diagonalization or something. So little depth is there for disadvantages. Those are same disadvantages what we have discussed here. A high amount of risk and uncertainty. Not a good model for the complex and object-oriented projects. So you can understood where you need to apply. People who are giving less amount, and once requirement finished, after that you need to do. For example, you are doing a small project at BTech level, you can apply waterfall model. Someone can design, and step by step you can start working. So that would be good if you are doing for a small project. Yes, adjusting scope during the life cycle can end the project. So once started, means delivery would be possible in the end only. You cannot deliver in between for testing purpose or some other purpose, and then you can further add some functionalities. That flexibility is not possible in this type of modeling. And next is iterative modeling, this is not in syllabus, but what idea here is you can understand from this particular block diagram. You can see here requirement, then build 1, build 2, and build 3. You can understand who was the build in the let me show you that initial block diagram where building was available here, right? Who were building? Developers. So now try to understand with this block diagram how the processing is done. So separate teams are working like finger like structure, you can say, parallelly going on. So this is called the iterative model. So iterative, this is it having a lot of practical application, and many industries are following as per their requirement. So iterative process starts with the simple implementation of a subset of the software requirement and iteratively enhances the involving version until the full system is implemented. So at each iteration, the design modifications are made and new function capabilities are added separately or individually. The basic idea behind this model is to develop a system through repeated cycles, what we call iterative. In the smaller portion at a time, or you are just doing incremental change, you can say incremental change means little bit you are doing incremental change or incremental addition and proceeding for the next step. So it's block diagram, and iterative and incremental development is a combination of both iterative design and incremental build model for development. During the software development, more than one iteration of the software development cycle may be in progress at the same time, and this process may be described as evolutionary acquisition or incremental build approach. So I will finish this one here. Few points regarding this, and the next is working model for the software development life cycle is spiral model. So why I just introduced with the iterative model, this is something just like the combination of previously two models what we have studied, what is called the waterfall model and the iterative model. So this we will see next. We'll start from here, but as a fundamentally you have to start from the some point and then at the one stage it ends, right? So small waterfall model start from here, it's get ended over here, then the like iterative model next will start and then again it will stop here, and so its working process go in the spiral way. In that way you can understand there are basically four phases, which are identification the problem, same as then the design, the architecture portion, and then the construct and build, what where developers are going to work, and then the evaluation and risk analysis. Customers feedback and some problems occurs, and whether it's functioning or not, even you can release the module after first completion of first cycle, and then you can test it, and then you can add new feature and you can start so on. So spiral like things will go on, and its bulk or size is going to increase step by step. So this is the idea behind this particular model. So I'll stop here, and if you want to ask something you can ask, otherwise I can sign off. Fine. So attendance I will take